In this video, we're doing an antiderivative with an even power of the secant function sitting right next to the tangent function. And the standard trick to these is that you split off a power of secant squared out of this integrand, and then we apply the trig identity. 1 plus tangent squared x equals secant squared x. And we could replace one of those secant squareds with this function in terms of tangent, and then everything's going to work out in terms of having the right differential inside this integrand. So let's see how it goes. So again, we split the secant to the fourth into secant squared times secant squared. Then I'm going to replace this one using that trig identity. Then I realize that what I'm left with is just powers of the tangent function when I distribute this tangent into those parentheses. So I have tangent to the first, tangent to the third, sitting right next to secant squared, which is the derivative of the tangent. So this is sort of automatically setting us up to see the chain rule backwards, or if you like, you could use a formal U substitution. I'm going to go ahead and distribute the secant squared in there as I go, and I have tangent x, secant squared x, plus a tangent cubed x, secant squared x. So each of those terms is a power of tangent sitting right next to the derivative of tangent. To really emphasize what's happening here, I could break it into two integrals real quick. And the first integral is just tangent to the first multiplied by the derivative of the tangent function. I recognize this as coming from the chain rule, operating on 1/2 tangent squared x. If that seems a little reckless to you, try differentiating 1/2 tangent squared x. You bring down the 2 out in front, it cancels the 1/2, and then you multiply by the derivative of tangent with respect to x, which is secant squared x. If you would prefer a formal U substitution on this, all it is let U equal tangent x, du is secant squared x dx. My second integral is a similar thing. I have a power of tangent sitting right next to secant squared, which is the derivative of tangent. I recognize that as a result of the chain rule, and I just run it backwards, and I get 1/4 tangent to the fourth, just using the power rule on the tangent function. Again, differentiating that, you'd bring the 4 down in front, subtract 1 from the exponent, and you've got tangent cubed. The chain rule says you've got to multiply by the derivative of tangent, which is why I was so happy to see these secant squareds floating around in my integral. So that's basically the integral, but it was an indefinite integral, and I should have a plus c on there, and we're done. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.